Hello everyone, this is Aditya, and today we're going to solve this question. In this, we are given that ABCD is a square and it has a side length of 1 units, and AGB and DEC are the equilateral triangles. So the region which is common in this, we have to find that region. So let's solve this. But before that, please do like, share, subscribe my channel, and please support this video. Now let's start. And as you all said that there was some issue in voice, so that is why I'm holding this mic right now, and I will buy a new one soon, right? So till then I'll be holding it like this, okay? So okay, so how can we solve this problem? Well, there are many methods to solve this kind of problem. So I'll be using a simple method. Of course, in that there will be lots of calculation though, using the coordinate system, and it will make the problem really simple. So let's see it, okay? So let's draw this here like this. So basically it will look something like this, okay? So it is like this, yeah, and like this, okay, correct. So let's mention a coordinate system over here like this. So these are x-axis and these are y-axis, correct? Okay, so this is our origin, correct? So these are origin. Since the side length is 1 unit, so that is why this coordinate will be 1 comma 0, correct? And it will be 1 comma 1, correct? And it will be 0 comma 1, right? So the idea over here is that I will find the equation of this line and equation of this line, and I will find the point of intersection of these two lines, and similarly I will find the equation of this line and this line, and I will find the intersection of these two. So let's see it, okay? So let's see. So of course we know that it is an equilateral triangle, right? So the coordinate of this point will be what? 1 by 2 comma root 3 by 2, correct? Why? Because if you all know, this is our triangle, right? Equilateral triangle, and if we draw its altitude, so we'll get this. So this angle 60 degree, this is 1 unit as per the question, sorry. This length is 1 unit, right? So it will 1 by 2 and 1 by 2, correct? Okay. So how do we find this length? Well, we can apply tan theta, right? So tan 60 is equal to what? Is equal to this length h by 1 by 2. So we get h is equal to tan 60 is root 3 by 2, correct? Okay. So we got the height as root 3 by 2. So that is why the vertical length is root 3 by 2 and the horizontal component is 1 by 2, right? So this point is this, right? Okay. Now similarly, of course, the x coordinate is still the same because it is along the same line, right? Of course, it is along the same line, right? But what will the coordinate of y? So we have to check that. Well, of course, it will also root 3 by 2, right? But since complete side length is what? Is equal to 1. So it will become 1 minus root 3 by 2, correct? Understood or not? This point was root 3 by 2, correct? And we have to find this length, okay? Or forget this one. So it was from the upward, it was like root 3 by 2, right? And whole length was 1, so of course it will be 1 minus root 3 by 2. Its length, its vertical length will be 1 minus root 3 by 2, and that is the value for the y component over here, right? Okay, so we have labeled most of the important points for the calculation, right? So let's see it further. So let me label the points also: a, b, c, d, and this one is e, f, g, and h, right? Okay. So let's find the equation of line FC, right? Or EC, you can say, basically both are same. So what is the slope of EC? Well, it will be root 3 by 2 minus 0 divided by 1 by 2 minus 1, which is equal to negative root 3, right? Of course, you should know how to calculate the slope of a line, right? Suppose if it is a line like this, x2 y2 and x1 y1, a straight line, then in that case slope is equal to y2 minus y1 by x2 minus x1, correct? Okay. So this is the slope. So equation becomes, we are applying the point slope form now. Y minus y1 is equal to m times x minus x1, right? So we are applying point slope form for this point. Y minus 0 is equal to negative root 3 x minus 1, correct? Okay. So from this you get equation as y is equal to negative root 3 x minus 1, right? Okay. So we got the equation of line EC. Now let's solve for uh, BG, right? Okay, so let's solve it. So what is the slope of BG, right? Okay. So we get the slope as 1 minus root 3 by 2 divided by the quantity 1 minus 1 by 2, which is equal to root 3 by 2 divided by 1 by 2, which is equal to root 3, right? Okay. So slope is root 3. Hence, again, we apply the point slope form for this point. We get y minus 1 is equal to root 3 into x minus 1, right? Okay. Now notice that we have to find the point of intersection of these two lines. So it is very simple. We can just add them, right? So basically we have these equation, this system of equation. I can write it like y is equal to negative root 3 x minus 1 and y minus 1 is equal to root 3 x minus 1. So we can see that they both are equal. So we can just add them. So this and this will get cancelled. So 2y minus 1 is equal to 0. So y is equal to 1 by 2, correct? Okay. So notice that f has some coordinate 1 by 2, right? Now what is the value of x coordinate in this? So let's solve for that. Okay. So let's see that also. Let's substitute y back into the equation in any of these equations. Let's substitute it over here. So we get 1 by 2 is equal to negative root 3 of the quantity x minus 1. So we get from this that x is equal to negative 2 root 3 plus 1, right? Okay. So it is negative, or we can write 1 plus 1 minus 1 by 2 root 3, correct? Okay. So this is the basic result for the point f. And of course, what we can do is that we can simply join these two lines, right? Of course, they will be parallel to this axis. It is just due to inaccuracy. It does not look parallel, but it should be parallel, right? Of course, you know the reason. It is simple. It is the property of equilateral triangle, of course. And you can prove it also very easily, right? Okay. So let's move further. So now let's calculate the point H, right? Okay, but you must be thinking that why I'm calculating these coordinates. Well, the reason is very simple. The reason is that since we know that these two are equilateral triangles, so of course if you break it like this, so of course we have got two regions and these two triangles have equal area. So if we are able to find the area of any of the triangle, we can easily solve for the other one, right? That is why. So we can just find the area of one triangle and then we can multiply it by 2, right? Okay. So let's see further how we can find for H. It is simple. Slope of AH, it is equal to what? It is equal to 1 minus root 3 by 2 minus 1 divided by the quantity 1 by 2 minus 1, which is equal to what? It is equal to negative root 3. Or you could have done it very simply that AH, or I mean AG you should write. Okay, that AG is parallel to FC, so that is why of course it will have the same slope as that one. Okay, right? And of course from this you proved it also, right? Okay. Now what is the slope? Wait, first of all let's solve for the equation. So we will apply the equation for point slope form for this point. Okay, so y minus 1 is equal to what? Negative root 3 x minus 0, that is x, right? Okay, so we got this expression. Now what is the slope of DE, right? It is equal to root 3 by 2 minus 0 divided by 1 by 2 minus 0, which is equal to root 3, correct? Okay. So again, we will apply point slope for this point. So we get y minus 0 is equal to root 3 into x minus 0. So basically, y is equal to root 3x. Just add these two, you will again get y is equal to 1 by 2, right? From this and this equation, when you solve for y, you will get 1 by 2. And when you substitute it back, you get x is equal to 1 by 2 root 3, right? So you get x is equal to 1 by 1 by 2 root 3, right? So it is 1 by 2 root 3 comma 1 by 2, correct? Okay. So we have got the coordinates of these two points, and we know the point E. So we know the coordinates of each point of this triangle. So let's apply some mathematics to solve its area. Let's see it. So let's solve for the area of triangle HEF, right? H H, that is 1 by, sorry, this is E. This is H. This is 1 by 2 root 3 comma 1 by 2, and this is F. It is 1 minus 1 by 2 root 3 comma 1 by 2, and this is 1 by 2 comma root 3 by 2, right? Okay. So what you can do is that you know that this length will be simply, you can apply the distance formula. What is the distance formula? Distance formula, it states that suppose you have a coordinate system x1 comma y1, and you have over here x2 comma y2, then the distance between them is given by delta x square plus delta y square, or simply root x2 minus x1 whole square plus y2 minus y1 whole square, correct? Okay. And you can extend this idea for 3 dimension, for 4 dimension, and so on and so forth, right? For spatial dimensions, I'm saying that is the dimension related to space, right? But we are not going to that. Okay. So basically its length will be simply, you can apply the formula, you will see the answer as uh, you can solve it easily. So it will be 1 minus 1 by root 3, right? You can check it on your own. So HF is equal to this length, right? Okay. Now you can draw a perpendicular over here, right? Of course, I know that it is also an equilateral triangle, right? How? Because of course this was 60, so this will be also 60, right? So this is also 60, right? I know that it is all 60, right? Okay. And secondly, I know that if this was 60, this is 30, this is 30. So 30 plus 30 is 60. So this angle is 120. So this angle is also 120. Now since these two are symmetric, so that is that this will be also 60 and this will also 60, this is also 60, this is also 60. So these both triangles are actually equilateral triangle, right? Okay. So I could have just applied the formula after this because I know one of the side lengths, but I'm just doing it for fun, right? Okay. So what is the vertical length? Well, at this point the vertical length is what? It is 1 by 2, right? So this is 1 by 2, and this is what? This is root 3 by 2. So we are calculating the vertical length, and since x is constant, this, so it is basically 1 by 2 comma 1 by 2, right? This coordinate, and this 1 by 2 comma root 3 by 2. So its length will be what? It will be root 3 by 2 minus 1, right? 1 by 2, correct? Okay. So now we have the base, we have the height, hence we have area of triangle is equal to half into base into height, which is equal to half into and one more thing. So we want the area of these two triangles, so basically we want twice the area is equal to actual area, which is the required area, is equal to BH, which is equal to what? Which is equal to 1 minus 1 by root 3 multiplied by root 3 by 2 minus 1 by 2, which is equal to root 3 minus 1 by root 3 multiplied by root 3 minus 1 by 2. So we get root 3 minus 1 multiplied root 3 minus 1 is root 3 minus 1 whole square divided by 2 root 3, right? And now you can simplify this expression. You get root 3 whole square plus 1 square minus 2 root 3, which is equal to 4 minus 2 root 3 divided by 2 root 3, which is equal to what? Which is equal to 2 by root 3 minus 1. So the area is equal to 2 by root 3 minus 1, right? Of course, I know that it was a really long method to solve this problem, and of course there are many other methods which you can use. It was just one of the method which I felt is a nice method to make you all aware of how you can solve a geometric problem using coordinate system, right? So it was interesting to do it like this method. You can easily apply other formulae or other methods also, like you can divide the area and do other sort of calculations to find this answer, right? there can be multiple approaches for a same problem, right? So you can tell me the other approaches of this problem, or let me know if my answer is correct or not, because I haven't checked the answer. So if you think that there's any issue in my calculation and in the answer, then please do let me know in the comment section. Bye bye, take care, and all the best.